Aren't you frustrated that you don't have any reviews for the chemistry final? Or tired of trying to find your chem notes when they're probably in the trash? Well, the Janae Go Cray course is here. This course will help you get an A in chem, so let's get started. First unit is Chemical Thermodynamics. Thermodynamics is the study of heat and its transformation to mechanical energy. Using word dissection, it would mean the study of heat power. Heat and temperature are often used interchangeably, but this is incorrect. Heat is the form of energy that is transferred between two substances at different temperatures. The direction of energy flows from the substance of higher temperature to the substance of lower temperature. Heat is measured in units of energy, usually in calories or joules. Temperature is the average kinetic energy of a substance. Temperature is measured in degrees on the Celsius or Fahrenheit scale, or in kelvins. In simplest terms, temperature is how hot or cold an object is, while heat is the energy that flows from hot to cold. Ever heard of H2O? When ice melts, it becomes water, and when it boils, it becomes steam. Doing this, we just made the phase change diagram. At 0 degrees Celsius is melting point, and 100 degrees Celsius is boiling point. The x-axis is heat, and the y-axis is temperature. The flat lines are phase changes, while the diagonal lines are temperature changes. Both changes cannot occur at the same time. When going up the graph, energy is being absorbed, which means an endothermic process is occurring. Melting and vaporization are the phase changes that occur when energy is being absorbed. When going down the graph, energy is being released, which means an exothermic process is occurring. Condensation and freezing are the phase changes that occur through this process. Specific heat is the amount of heat per unit mass required to raise the temperature to 1 degree Celsius. The equation to find specific heat is Q equals mc delta T. To break down the equation, Q is the heat energy in joules, m is the mass in grams, C is the specific heat in joules over grams times Celsius, and delta T is the change in temperature measured in Celsius. Here's an example of a specific heat problem. Calculate the amount of heat needed to increase the temperature of 250 grams of water from 20 Celsius to 46 Celsius. We are asked to find Q. M is 250 grams. To find C, it is the specific heat of water, which is 4.184 joules over grams times degrees Celsius. The change in temperature is the final temperature subtracted by the initial temperature, which is 26 degrees Celsius. Now to put all these values in the equation, the answer you would get is 27,196 joules. There is only one sig fig, so the answer is 30,000 joules. Latent heat is the heat required to make phase changes without the change of temperature. The formulas needed are Q equals m times h of f and Q equals m times h of v. Q is the heat energy in joules, m is the mass in grams, h of f is the heat of fusion, which is used when the phase is changing from melting or freezing, and h of v is the heat of vaporization, which is used when the phase change is changing to vaporization or condensation. Keep in mind when the substance is going through freezing or condensation, the value is negative because these processes are going down the phase change diagram. Let's go through an example. How much energy is required to melt 4 moles of ice at its melting point? Assume that the molar heat of fusion of ice is at 6 kilojoules over moles. Melting is the phase change that's occurring, which means Q equals m times h of f is going to be used. We are asked to find Q. M is 4 moles and h of f is 6 kilojoules over moles. The answer you will get is 24 kilojoules. Since there is only one sig fig, the answer will be 20 kilojoules. This is the end of the Janae Go Cray course. Hopefully this helped you prepare for your chem final. If not, well, thanks for listening anyways. Good luck!
Created using Powtoon.